All right, we're going to go ahead and get started here. Again, thank you all for joining us. Hello, everyone. I'm Jen Weesey, and I will be your moderator for today's webinar. I work for the Grails and Micronaut team here at Object Computing, and we'd like to thank you for joining us today. We are really excited for our guest presenter today. He is the Oracle Developer Advocate and Todd Sharp. So in this complimentary webinar, Todd will show us how to create a simple Micronaut microservice and develop it to the Oracle Cloud. So with that, I will pass it over to you, Todd.
Thank you so much, Jen. I appreciate it. And to all the folks at OCI for having me here today to talk about this awesome topic of how to build and deploy a cloud-native microservice to the Oracle Cloud. As Jen said, I'm Todd Sharp, and I am a developer advocate for cloud and database. Let's get started. This is Oracle's safe harbor statement. Basically, don't buy anything based on what I'm saying today. And this is me. So I am currently, as I said, a developer advocate at Oracle. I work on the database team currently, but I advocate for basically anything cloud related, cloud database, cloud native, cloud, whatever you want to call it. Previously, I worked at AT&T and a government consulting firm here in the States called Booz Allen Hamilton. I have, let's see here, yes, that number still is accurate. I have 16 years of full stack experience, starting with Cold Fusion. Raise your hand if you care to admit that you worked with Cold Fusion, and then with Groovy, Grails, and ultimately onto the Java world. I also dabble a little bit in the dark side, and that is JavaScript, Angular, and Node, and I'm not ashamed to admit it. So here's our agenda today. We're going to do a lot more coding, spend a lot more time in the IDE than we're going to spend in these slides, and I think you could all appreciate that. But what we're going to do is we're going to create a simple Micronaut app. We're going to set it up for CI/CD via GitHub Actions. Then we're going to look at some other cool things like distributed configuration. We're going to configure the application for basically using Micronaut data to do some persistence and so on and so forth. Excuse me. Before we move forward, I must first assert that OCI does not equal OCI. And what I mean by that is, as you can see on line 2 here, when I talk about OCI, unless I am qualifying it, OCI to me means Oracle Cloud Infrastructure. It's kind of an unfortunate coincidence that it also stands for Object Computing Inc., who is the company behind Micronaut and Groovy and Grails. But when I talk about it, I'm talking about Oracle Cloud Infrastructure. So I'll try to be specific, but if you do hear me say something OCI, 99% of the time I'm referring to Oracle Cloud Infrastructure. So if you go to the Micronaut website and look at the documentation, you're going to see this phrase, natively cloud native. Now, what is natively cloud native? What does that mean to us? Well, as I said, I've been a full stack dev for 16 years now, going back to 2004. And as I think back at my time in development, right before the cloud era, if you will, we had a lot of different concerns when it came to our applications. And if you go back to the monolithic or macroservice type era, we had different concerns when it came to our JVM applications, right? We didn't care so much about startup time, for example. As long as the app started up, it didn't matter if it took 60 seconds or 10 seconds. As long as it started up, that's fine. It's cool. Coming from the dynamic side of things, we didn't care about runtime, we didn't care about anything related to memory consumption when it came to using things like reflection or things like that. So now that we're in this kind of cloud native era where we're relying on these cloud providers to do our hosting for us, and we're getting into things like microservices, we're getting into things like serverless applications, serverless functions, we're caring a lot more about startup times. We're caring a lot more about memory consumption. We need to be aware of the environment because we might be running in 2 different clouds. We might be running locally. We need to know if we're running locally. We need to we're running in a test environment, we need to be environment aware. We're using things like distributed configuration because it's a lot harder nowadays to store sensitive data in, obviously you don't want to store that in your application. So we're using distributed configuration stores to store sensitive data like secrets. Service discovery, distributed tracing, serverless functions, as I said, these are the things that are baked into Micronaut. The framework was built kind of after the cloud era began. So it was built with the cloud in mind from the ground up. And I hope I'm doing that justice. I'm not obviously one of the people behind the framework. I have contributed to it, but I'm not one of the founders or creators. So I hope Jeff and James that I've done that justice. But essentially, that's what being natively cloud native means to me. So let's build one. I mean, enough talking. We've talked for 5 minutes now. Let's actually get into the editor and build one and look at what it takes to create and deploy that to the Oracle Cloud. Spoiler alert, it's really easy and it's really fun, and let's get to it. So step one is to actually create the application. And I've already done some of that for us. I've just scaffolded it out, a basic application with the Micronaut CLI here. And I've created a remote GitHub, or I've created a GitHub repository, and I've done an initial commit. So I have just this basic Micronaut application here. And basically all I have here is an application.java file and an application.yaml file. And what I've added is support for Micronaut data JPA. So I've got those dependencies all in my build.gradle script. And the next thing we're going to do here is create a simple controller. So we're going to do that with the Micronaut CLI, and we're going to call create controller. And right off the bat, we've already got an issue here. Lovely. mn create controller. All right, so we're having an issue in there. Let's try to come over here and run it from my terminal over here. Awesome. All right, we've got our controller now. So if we open that up and take a look at it, we can see we get a basic index slash endpoint for our controller. Now, if we modify that slightly, we're going to produce some JSON, and we're going to return a map. So if we come down here and we say return map of hello world, and add our semicolon because we're not working in Groovy, unfortunately, and get our import. So, all right, everything looks good. Now at this point, we can come over to our application.yaml file, and every application needs configuration, right? I mean, this is basic building block 101 of web application development. We're going to need to use configuration variables in our application. So if we come over here and create a simple test, we can say this is localhost, and now we have a application configuration variable called codes.recursive.test. And if we come back over here to our controller and add a constructor, we can inject that into our application. So we say codes.recursive.test, and we create a field for it, and we can then return that in our default controller method. All right, so we should now, if we start that up and give it just a second, we should have a endpoint, a default endpoint for the /hello path that will return a map containing two keys, one key called hello with a value of world, and another key called test with the value this is localhost as shown here, right? All right, so let's take a look. All right, our application started up. Come over to terminal, and we'll curl that endpoint. As you can see, we've got that map returned to us. Very simple, very basic, and we've got an application, right? We have an endpoint that returns some data. And technically, by the letter of the law, we have a microservice. So yay us. It took a whole 4 minutes or so, and we've got a microservice created. Let's move on to the next step. And the next step is going to be setting up CI/CD. So if we come over here to our root of our project, and we create a new file, we can call it github.github, well, the GitHub directory, and workflows, and we'll call it Oracle Cloud.yaml. Now, essentially, when you're working with GitHub Actions, you can use, of course, any CI/CD tool that you're comfortable with. I happen to be learning a lot about GitHub Actions lately, so we're going to use that. But if you use Jenkins, if you use GitLab, whatever you use is fine, and you'd obviously have to modify it accordingly. But in the microservice world, in the cloud world, it really, it's very important, as we all know, to have a continuous integration and a continuous deployment pipeline. So we're going to create that, and to do that with GitHub Actions, at least, you create this directory structure of .github/workflows, and then whatever you want to call the file, .yaml, and you have to follow the GitHub Actions YAML schema, but it's really simple to do. And I've got some snippets that will help us populate that. So the first thing we're going to do is say on push of all branches, we're going to run this build job named build job. And to get started doing that, we just simply start adding some steps to our job. The first step we're going to do, because GitHub Actions runs everything on what's called a runner virtual machine, and obviously not in the GitHub server, GitHub universe. It actually is a runner VM, I believe a Docker image, but that doesn't matter. The first thing we're going to have to do is check out our code, right? So we're going to use the action, the checkout GitHub action to check out our code. And that's going to establish a local workspace directory right on our runner. The next step is going to be set up Java 11. So the runner VMs are all pre-configured with various Java versions out of the box. And we want to use Java 11, so we're going to use this setup Java action to set up Java 11 to do our work here. And really easily, since Gradle is pre-installed in the runner, we're going to call Gradle W, the Gradle wrapper, and we're going to call the assemble task. And the assemble task is going to do what it does, the same thing it would do if you were doing this locally, right? It's going to assemble a jar file for our Micronaut application. So next up, we are going to add a few more steps. And the next step we're going to do is grab the version number. We're going to call Gradle W properties. We're going to grep that out, grab the version number, the current version number for our application. And then we're going to publish this jar, right? So like any CI/CD service, you want to publish the artifacts from your build. So in this case, we're going to publish a jar file as a result that is the result of the assemble task. And it's going to be available so that we can always come back at any point in time, look at this build and grab that artifact and take a look at it if we need to. So after we publish the jar, what do we have to do next? Next thing we're going to do is get ready to create a VM in our cloud. So in order to do that, we need to do a little configuration. And to do that configuration, in the case of the Oracle Cloud, we're going to use this CLI to create our VMs and do our tasks with the Oracle Cloud. So with the Oracle Cloud CLI, what we have to do is create a directory in our home directory called .oci. And in that directory, we're going to have a file called config. And this is going to contain the information that the CLI needs to connect up and do its thing. So in order to do this, I've stored a series of secrets in the GitHub Actions, and we can access those by using the secrets prefix and then calling our particular values like so. So in this case, we're setting a user fingerprint, passphrase, so on and so forth, and we're writing these all to the runner VM disk. The next thing we're going to do is install the OCI CLI, And that's just a matter of calling curl and then executing the install script. And finally, calling a few repair file commands to make sure that everything is set up to the proper permissions. And the next step in our build is going to be to create the instance, right? So before we create the instance, we first want to make sure that the instance doesn't already exist. And in order to do that, we're going to call the OCI compute instance list command from the CLI. And we're going to check for VMs that are running in the compartment ID that we are specifying by the name mn-OCI. We're going to store that in a variable called instance OCID or OCID. I call it OCID. And that environment variable will be available for use in our other steps in our job. So once we check if the instance exists or not, and basically if it does not exist, this will be null, we can come down here to the next step, and that is create the instance. So if it doesn't exist, if the environment.instanceOCID does not exist, we will run the OCI compute instance launch command, as you can see here, and pass it some various variables. The shape, I've created a custom image based on that has Java installed, so that out of the box we're ready to go. And that custom image OCID is stored as well in a secret. But basically, I pass it everything it needs to know. I store all of that in secrets in that repository, and I create the instance. All right, let's move on. The next step is to grab that instance's IP. And again, we're using the OCI CLI to do that. And next thing we're going to do is wait for SSH, because if we're creating a new instance here, a new VM, it's not enough because we are telling it that we want to wait for state running, but it's not enough to just wait for a VM to be running. Just because a VM is in a running state does not mean that SSH is ready for connections. So in order to do that, we just run this loop and sleep if it's not available until SSH finally responds. And that way we know that it's ready for commands. Next thing we're going to do is stop the app. So we're going to use this SSH action GitHub action, and we just pass it the instance IP address that we grabbed above. We use our VM SSH private key that we stored in a secret, and we simply do PSAUX to list out our running processes and look for a process that is running with our jar file. If it's not found, then we just simply echo out not found. Otherwise, we kill it. Okay, so we're just making sure that the application is not running. Now, obviously, this is kind of a simplified example here. We're just running Java jar for our Micronaut application. You could be using, you could be packaging your application up as a Docker image, deploying it to Kubernetes, and obviously there are certain various GitHub actions that you can use in those scenarios. But we're keeping it really simple here. We're just going to stop the app on just a regular VM machine, and we're going to stop and start the app and use that for our deployment process. If you're interested in learning more about the Docker or Kubernetes flavor of this, I do have a series of blog posts that I'll tell you about at the end, as well as an actual book that this is all summarized in that you could read and refer to for more information on that. All right, so we stop our app. Next thing we're going to do, obviously we need to push our app up to the server. So we have this build on our runner VM. You have the jar compiled up, ready to go. And we just need to push that up to the VM. So we're going to push that using the push jar step. And finally, if you could take a wild guess as to what the next step is going to be, is we're going to start the app, right? So we stop the app, we push the jar, and now we start the app. And everything should be, in theory, good to go. Now we want to make sure we use no hop. Otherwise, as soon as this process completes, that process will go away. So we want to make sure we start it and run it in the background, basically, and make sure that it's not hung up on as soon as our job is done running. As soon as our connection disconnects, I should say, since we're using the SSH action GitHub action here. We're going to store our content, our output, in a log file. that uses basically a timestamp within the name, so that we have our log output all good to go. Now, before we push this and run this, let's do one more thing, and that is going to demonstrate a really cool feature that I think is really handy to have in Micronaut, and that is we're going to create a configuration file called application oracle oracle cloud.yaml, and we're going to populate that with the following. So as you can see here, if we look back at our application.yaml, we have a variable called codes recursive test, and it says this is localhost. And basically what we're doing here is we're overriding that when it comes to the Oracle Cloud environment. So Micronaut, it seems like a simple feature, but when it comes to these cloud native applications, it's really important to be able to specify configuration per environment, right? A lot of times when you're working on applications, you may have a different API key for your test environment, you may have a different API key for your dev environment, so on and so forth. You may be using different object storage buckets, for example. You may have different passwords, different credentials for your database connections, things like this. So it's very important to be able to intelligently provide environment-specific configuration. And this is the really easy way of doing that with Micronaut. So what's going to happen now is if we come over here and we make a commit to our GitHub repo, and we push that, all right. So our push is complete. And if we come to GitHub and take a look, we will see that our build job is now running. So GitHub has detected the commit within this repository, and it's starting to run the job. It's going to do all the steps that we've just specified in that configuration file. And once it's complete, we'll get a little notification. We're not going to sit here and wait for that. We'll move on to the next step, and we'll come back and take a look at the result of that when that build is complete. So what's the next thing we're going to take a look at? Well, as I said earlier, one of the important things about the cloud native development is that you have the ability to use distributed configurations within your application, right? Now, we just took a look at environment-specific configuration, but what is distributed configuration? Well, distributed configuration is the ability to store sensitive data in a store, something like HashiCorp Vault, something remote that stores our sensitive information, because obviously we don't want to put plain text passwords in our environment configuration files, and we definitely don't want to put those into source control. So how do we solve that problem? We use distributed configurations. And in the case of OCI, Oracle Cloud Infrastructure, we have something called the Oracle Cloud Vaults. Now, Micronaut has support for HashiCorp Vault. It has support for AWS Parameter Store and many other different services. So it's not specifically, this feature is not specific to Oracle Cloud Infrastructure, but I'm going to show you, because I'm a Oracle Cloud Infrastructure advocate, I'm going to show you our version of this and how to work with that. So we're going to log in really quickly to the Oracle Cloud Console, because apparently I was logged out. And once we get into there, you can see this really nice console. If you've never seen it before, this is the beautiful Oracle Cloud Console. And we start by clicking Security and then Vault. Let me change my compartment to make sure that I'm using the correct compartment. And as you can see here, I have a list of vaults that are shown on this Vault landing page. Now, I've already created one that we're going to use shortly here, this mn-oci demo vault, but let me show you really quickly how you navigate through here and create a vault. So the first thing you do is click on Create Vault, you give it a name, and then you click Create Vault. Once that's complete, we're not going to do that right now because we already have one. Once that is complete, we can click into the details of our vault, and we can scroll down here and see on the sidebar over here, we have master encryption keys and we have secrets. So in order to create secrets, we first have to create a key. So we give our key a name, we choose the algorithm, AES is your current only option, and then you choose your key shape, your length. Once you've created your key, you can then start creating secrets. So if you come over here to secrets, you click create secret, you give your secret a name, a description, and choose the key that you want to encrypt that secret with, and then choose either plain text or base 64, enter your contents, and click create secret. So you can see here, I've already created a secret called foo, and it contains the string bar. So how are we going to use this in our Micronaut application? Well, if we come back over to our application, we first need to add a few dependencies to our build.gradle. So if we come over here and add those dependencies, you can see that I've added the Micronaut discovery client, as well as 3 different OCI SDK dependencies, and this is all defined in the distributed configuration documentation in the Micronaut docs. But essentially, in order to use the distributed configuration for OCI Vault, we need these 3 dependencies from the OCI Java SDK. Now, as I said, we've created all of our various secrets in the Oracle Cloud. So the only thing we need to do at this point is create another configuration file over here, and this one is called bootstrap.yaml. And this is going to run basically before anything else happens, and these variables that we're going to get from our distributed configuration will be available in our application configuration files, as we'll see in a minute. So we're going to populate our bootstrap.yaml file, and you can see here that I've done that. And I have this Oracle Cloud Vault configuration in my YAML file. Now, this again is all documented in the documentation, but you have the ability to define a list of vaults. You can create as many vaults as you need in the Oracle Cloud. And in my case, I've created just one, and you have to pass the OSID of that vault, as well as the compartment that the vault resides in. But if I wanted to add more, I could come over here and I can add additional vaults just like this, and as many as I need. Now the catch is, what's going to happen is the distributed configuration is going to read all of your vaults, and it's going to create a configuration variable in your application with a name that matches exactly the name of your secret in your vault. So in our case, we had a secret created named foo, and there will be a configuration variable in our application available called foo. And what does this mean? This means if you have any secrets in multiple vaults that have the same name, it's going to be a problem. The last one, basically red, is going to win that fight. So you need to be careful how you're naming your secrets and make sure that you don't have any conflicts. The next configuration is whether or not to use instance principals. Now for this demo, we're not going to use this.
I'm sorry to interrupt you quickly.
Yes, sir.
So there's a question about whether or not you can create vaults and issue secrets using an API or a CLI.
Absolutely. Good question, Jeff. Thank you for breaking in there. Absolutely, you can. You can create vaults and secrets via any of our SDKs, being the Java SDK, the TypeScript SDK, the Python SDK. Any of the SDKs that we offer have the ability to create vaults and secrets, as well as the OCI CLI. You can create them directly from the OCI CLI. I don't think I have a link to the blog post, but I do have a blog post that I can probably share at the end here that has an example of that. Thank you, Jeff. So use instance principal. What is an instance principal? Instance principals are a way to utilize the SDK on a Oracle Cloud Vault without specifying or providing any configuration files. So We're not using them. So what we have to do is make sure that that configuration file that we did in our runner VM, we need to make sure that that also exists on our VM so that when we use the SDK, it can properly authenticate and sign all of our requests. If we were to use instance principals, that would not be necessary. Instance principal authentication is really cool. It just takes a couple of steps to enable for your VMs, creating some dynamic groups and some policies around those. And then you don't need to do any configuration. You just use instance principal authentication. It snags some values out of the environment variables that are set for you on that VM, and authentication is all handled. So the Vault configuration feature for OCI and Micronaut does support instance principals. Check out the docs for more on that. And just a few other variables that we need to define here: the profile within our configuration to use, because you can specify multiple profiles in a config, as well as the default region. In this case, we're going to use Phoenix. All right. So as I said, we should now have a variable called foo. And at this point, we can do things like this. We can inject that directly into our application.yaml file. So at runtime, we should now be able to come back over to our controller, and we should be able to get the value of foo at runtime. So if we create a field for that, inject that into our controller, and if we include that in our map over here and rerun our application, we should see that as soon as that's done. Let's take another peek over here back at our job and see what happened. Okay. Let's take a look. All right. Okay, excellent. So our job ran successfully. We can see that it skipped the create instance step because I already had an existing instance named mn-oci, but otherwise it created our artifact and it uploaded it here, so published it here so that we can download that and take a look at it in the future. But at this point, if we come over here and we take a look, we can see that our output log was created and that it established the active environments Oracle Cloud and Cloud, and startup is completed. So if we curl localhost here, we can see that, as I said, because we are in the Oracle Cloud environment, the application.oracle cloud configuration was picked up and the value is shown in the /hello endpoint. All right, so we can see that is the result of step one. Now, if we come back over here to our next demo for the distributed configuration, you can see down here in the console, a whole lot of different information is spit out in addition to the normal startup completed. Now, what is all of this information? Well, this is the information related to loading our secrets. So we can see that it loaded the secrets. The secret service, we can see that it loaded the vault service behind the scenes, and all of the information related to grabbing that vault configuration, secret configuration values is logged out here in our console. Now, if we do another curl really quickly, we can see the value of bar was retrieved for the secret foo. So again, this is really cool. This is really handy. We'll see in the next step how we can take advantage of this in a more applicable example, shall we say. All right, so let's move on. What is the next step? The next step is to configure application for CRUD support. So as I said, we used Micronaut Data JPA when I created this application. So we're going to go about adding support to our application for that. first thing I'm going to do is illustrate to you the fact that Oracle Cloud support, Micronaut has support for universal connection pooling, which is an Oracle, basically, I guess you could say, competitor to Tomcat or Hikari for connection pooling. So we can use that by changing Micronaut JDBC Tomcat to Micronaut JDBC UCP. Next thing we're going to do is, oops, not that. Next thing we're going to do is add our OJDBC drivers. So we're going to hook up to an Oracle Autonomous Database instance in the cloud. So we're going to need the OJDBC driver to do that. We're going to delete H2. And next thing we're going to do is come over to our application.yaml file, and let's wipe out this H2 data source, and let's add a data source pointing to our autonomous database. So autonomous database is, if you're not familiar with it, is basically Oracle database in the cloud, and it's called autonomous database because it is completely autonomous. It's self-driving, it's self-healing, it's self-patching, it's self-updating. It manages creation of indexes for you. It manages backups, all that stuff. So for someone like me, and I hate to say this being that I'm in the database organization, but for someone like me who's not a DBA, not exactly 100% comfortable in the database side of things, it's really nice because it handles all that stuff for you. It's basically just click, drag, click and run type database. And what we have with the autonomous database is this concept of a wallet. And a wallet is basically it's just a zip file. And if you download the wallet through the console dashboard on the web, you can also download it via the CLI or the SDK. But if you download this wallet, it gives you essentially it gives you a certificate that's used to establish secure connections to your database. So you still have your username and password, but in order to use SSL TLS connections to your database, this wallet contains the files that are necessary behind the scenes to make that connection secure. So I've created my data source here. I have a username test user, and you can see here where distributed configurations in the vault really come in handy. Obviously, I don't want to store my database password in my application.yaml file, and I certainly don't want to check that into source control. So I've created a vault secret called db_password, and at runtime, that will be ready to go for me. I'm using create drop. You obviously never want to do this with a real application, but for a demo, it works just fine. So let's pretend like you don't see that. And let's move on. So we have a data source created. The next thing we're going to do is come over to our application.java file. And really quickly, we're going to add this statement to disable fan. What fan is well, we're running short on time, so I don't want to go too much into it. It's basically not something you're going to use unless you explicitly know what you're using. And you can disable it by setting this system property like so. Did I miss something? Let me check here. I don't think I missed something. I did miss a quick step, but let's add that really quickly. We need to add a step over here in our job, even though we probably won't demo this. But essentially, we want to make sure that we have that OCI config on our virtual machine as well. Like I said, we're not using instance principal auth. So the next time we run this job, this will write out the OCI config to our VM so that if we were to push and deploy this application, it would be able to use that going forward. All right, back to our build.gradle. Because I'm super lazy, let's add Lombok. And we want to do that up near the top because read the documentation for why, but essentially if you don't put that above one of the other Micronaut dependencies, you're going to run into issues, and it's explained in the Micronaut documentation. So I added Lombok. What else are we going to do? As I said, we created a wallet, or we have a wallet So we're going to make sure that that wallet exists on our VM as well, even though we're probably not going to demo this step on the VM. But just so you're aware, when you're using this wallet, I've stored all the contents as base 64 up in GitHub secrets, and we're going to write those out to the VM so that when we push and deploy this application, it exists and can be used by our running application. All right, let's get into the fun stuff now. Let's get into creating a domain object. So I named it wrong. Let's rename that. Awesome. All right, so if you saw Graham's session 2 weeks ago, or if you've done any work with it, a lot of this is going to be hopefully familiar to you, but if not, awesome, we will learn together right now. So we're going to create this entity called person, and we're going to create, add an annotation for @entity, add @table annotation. This will be the table name that's created for us. And we're also going to want to refresh our Gradle dependencies because for some reason IntelliJ doesn't want to do that automatically anymore. But we're going to want to wait until that's done and come back. And we're going to create some properties. So we're going to create an ID property, and that's going to be a generated value. We're going to want a getter and a setter. And that's going to be a long ID. And we're going to add a few other properties. So this is basically just our person domain object. So we're going to add a few properties to represent a person. Last name. We can also do the awesome Java validations. So we're going to add a size constraint here for first name, and let's just be silly and say our first name and last name have to be between 1 and 10 characters, right? Because that's a reasonable validation rule for our form. Actually, it's not, but it'll help us to demonstrate things. Let's see, there we go. So now that Gradle has decided to catch up with me, I can import these classes. Awesome. So we have a noargs constructor. We have a getter setter. I am weird and I like my annotations on the same line. So let's add one more property. Let's add an age for our persons, and we'll say min. So let's say our users have to be between 1 and 125 years old, right? Because that seems reasonable. Why not? And let's add just 2 more properties to our user. And these are going to be dates. Oh, stop it. All right, so one of the cool things about Micronaut data is similar to Grails and certainly many of the other similar frameworks. We have these magic properties called date created and date updated. So these are auto-populated for us when we do create a new object or we update an object, but they're really cool, really handy to have. Let me zoom in here so you can see a little better. Sorry about that. And let's do a constructor for our first name, last name, and age. All right. That all looks good to me. The next thing we're going to do when it comes to Micronaut data is we're going to create our repository. So we're going to say, create another Java class called person repository. And this is actually an interface. And we just annotate that with repository. And we extend, we'll keep it simple, and we'll extend CRUD repository person long. All right, so as you can see here, this is our interface. And the next thing we're going to do is come back to our controller and add a few endpoints to use that interface. Actually, first we're going to have to inject that interface. Awesome. Now we have a beach ball. There we go. Okay. So we'll add a get method for persons. And since we have all of these out of the box, we have the awesome basically free CRUD out of the box with Micronaut data, right? Because we extended CRUD repository, and if we come back over here and if we take a look really quickly at CRUD repository, right, we get all of these methods out of the box. And at compile time, Micronaut is intelligent enough based on the properties that we've provided, some of the annotations that we've provided, and some other various things. It's intelligent enough at compile time to generate all of the necessary queries for save, update, save all, find by ID, exist by ID, so on and so forth for our person object, right? And it does all this at compile time. It stores it in annotation metadata so that it's all ready to go, ready to execute at runtime. So we don't have to store all that like we did in the old days. We don't have to store all that in memory, all of that runtime performance effects that we would get back in the day when we did these sort of things at runtime. That's all taken care of for us, and it's all done at compile time. And again, please check out Graham's talk for much more of the intelligent knowledge about that topic. But essentially, it's like a magic wand. We wave it, and we have instant CRUD methods in our application, right? So let's add another method to get a person by ID, and we'll call it get person, and person repository dot find by ID, and we got that. And we'll add one more method to save persons, right? So we'll call that save person, and we save. Oops. All right, excellent. So the last thing to do here is to run the application. And while that launches, since we're getting a little short on time here, let's move forward a bit. So one of the things that I wanted to talk to you about and show you here, so essentially we've built our microservice, scaffolded it out in less than an hour. We've added environment-aware configuration. We've added distributed configuration for sensitive values. We've created a CI/CD pipeline and actually built a VM and deployed our application to that VM. And we've added full CRUD support that points at a autonomous database instance in the cloud. And once we get back and test that, you'll see that everything works just as expected. We've done this in 45 minutes. Some of the other things you can do that you would obviously want to do is you want to add testing to your application, right? So how do you do that? Very simply, you add some steps to run the tests and publish your test reports. So Gradle W test, and you can add Spock tests, JUnit tests, whatever your favorite flavor of testing framework is. You add all your tests in, and here's an example using Spock and test containers to use an Oracle database container. And you can add all this to your build and execute all of your tests in your GitHub pipeline and integrate it just like you would any other normal CI/CD pipeline. Another thing that's really cool about Micronaut is that it has support for schema migrations. I believe it has support for Liquibase and Flyway. I could be wrong, but I'm 95% sure that those are the two that it supports. And to do that, you add a Micronaut Liquibase dependency and make sure that you have the JAXB annotations included. And then you just configure it. You just tell it Micronaut where your changelog exists on the file system, you create a changelog. In this case, we're using the XML changelog for Liquibase, and you just point in your changelog include all of your change set files in your changelog. And then here's an example of that change set file that you would use to create a users table, for example. You just define your create table operation, define all your columns. And once you do all this, you deploy it deploy it with your application. During your build, Micronaut is going to execute those migrations as just magically, essentially. You just, as part of the deployment process, part of the build process, when you run your app, all your schema migrations will be done for you. Awesome. So we can see over here in our console that our application is now running. If we come over here to Postman and submit some requests, so in this case, I have a JSON representation of my user, and we send that. We can see that our user is created, and we have an ID of 166. If we try to save an invalid person, we get a list of errors back. In this case, we had a first name and a last name that were too long and an age that was too old, because obviously nobody is 143 years old. And we can get our person by ID, and we can also get all persons. So we get a list of persons back there. If we take a look quickly over here at SQL Developer, we can see that our table was created, and just as we expected, it has the ID, age, date created, first name, last name, and last updated columns. And because we've only called the save method once, we have one user created in our table. All right, so jumping back to the slides. So as I said, you can do all this. You can deploy all your Micronaut application to the Oracle Cloud, but there's a catch, right? No, there's not a catch. Actually, you can do all of this absolutely free. And I'm not a salesman, and I'm not here to give you a sales pitch, but I am here to tell you that this is really cool and really awesome. And I actually use this myself for my own personal projects. You can get forever, for free, 2 autonomous database instances, up to 20 gigs of storage, 2 virtual machines. Now, they say 1/8 of a CPU and 1 gig of RAM each, but honestly, for a side project, for a blog, for a forum, things like this, I've run all of these types of things on the free tier, and the machines are perfectly capable machines to handle minor workloads like that. You get 2 block volumes, 100, basically your boot volumes, 50 gigs each. You get 10 gigs of object storage and archive storage, and a load balancer. You get a certain amount of bandwidth. And also, as you can see here on the bottom right, you do get 5,000 vault secrets included in the free tier. So if you wanted to use that distributed configuration that I showed you, you can do that absolutely free. You can do essentially everything that we've done here today absolutely free on the always free tier of the Oracle Cloud. Check that link at the bottom of the slide there, oracle.com/cloud/free. Tell them Todd sent you, and they will give you nothing extra on top of that. I wish I could tell you they did, but at least you know that you get the free tier for free. If you're interested, this is, again, not a sales pitch. If you're interested in reading 10 chapters of this entire presentation, basically from start to finish, with more details, with details about test containers, with details about Liquibase integration migrations, with details about Docker containerization and deploying to Kubernetes. It is all in the book. You can see it's available here, bit.ly/mn.-oci-book. But if you're not interested in purchasing it, you can read all 10 different blog posts for absolutely free by checking out my blog on the Oracle Developers blog. These are the links to those. The final code for this is also available up on GitHub if you want to look at all the code that we just worked on today. There are the rest of the links for the 10 posts in this blog series, as well as a few additional links about, and actually I think that second from the last one there includes information about creating a secret via the CLI. I'm almost positive. Actually, it might be the bottom one. I think it's the bottom one. If you're interested in contacting me, you can do so on YouTube, Twitter, my blog, GitHub, LinkedIn. You can email me. You can send me a carrier pigeon, however you want to do so. Make sure you keep the appropriate social distances when you do so. And I really want to say thank you for attending. Thank you to the OCI, non-OCI people for having me.
Thank you, Todd, so much. We appreciate you and your time doing this. We want to, again, thank everyone for joining us, and hope to see you again in a week for our next Micronaut webinar. Yvonne will be talking about Micronaut testing, so we'll hope to see you on that one.